Hello everyone, this is Tu Yuan. Today I will share our recent work, MotionEditor, editing video motion via content-aware diffusion. Existing diffusion-based video editing models have made gorgeous advances for editing attributes of a source video over time, but struggle to manipulate the motion information while preserving the original protagonist's appearance in the background. This raises the questions, can we manipulate the motion of a video in alignment with a reference video? In this paper, we attempt to explore a novel, higher level, and more challenging video editing scenario, motion editing. Given a reference video and prompt, we aim to change the protagonist's motion in the source to match the reference video while preserving the original appearance. Our contributions are as follows. We are the first to explore the video diffusion models for motion editing, which is usually ignored by previous video editing works. A novel content-aware motion adapter is proposed to enable the control to perform consistent and precise motion editing. We propose a high-fidelity attention injection mechanism that preserves the background information and the geometric structures of the protagonist from the source. The mechanism is only active during inference, making it training-free. As is illustrated in the figure, MotionEditor is based on the commonly used text-to-image diffusion model and the control net. We first inflate the spatial transformer in the U-net of the latent diffusion model to a 3D transformer by appending a temporal self-attention layer. We also propose constant sparse attention to replace the spatial self-attention to achieve precise motion manipulation and temporal consistency. We design a content-aware motion adapter operating on features from the U-net and conditional pose information from the control net. Following turn a video, we performed one-shot training to compute weights from the temporal attention module and the motion adapter to reconstruct the input source video. Our goal is to manipulate the body motion in video under the guidance of pose signals. While control net enables direct controllable generation based on conditions, it has difficulties modifying the source motion from the inverted noise. Therefore, we propose a temporal constant-aware motion adapter that enhances motion guidance as well as facilitates temporal consistency. Our motion adapter takes as input the future output by control net, which has been observed to achieve promising spatial control. The adapter consists of two parallel paths corresponding to different perception granularity. One is the global modeling path, including a content-aware cross-attention block and a temporal attention block. The other is the local modeling path, which uses two temporal convolution blocks to capture local motion features. Although our motion adapter can accurately capture body poses, it may undesirably alert the appearance of the protagonist and the background. Consequently, we propose a high-fidelity attention injection from the reconstruction branch to the editing branch, which preserve the details of the subjects and the background in the synthetics video. We now present the injection of keys and values from the reconstruction branch to those of the editing branch. For CS attention, we leverage a source foreground mask obtained from of the shared segmentation model to decouple the foreground and the background information. Notably, simply replacing the key or value in the editing branch with the above ones will cause a large number of eruption motion changes, as the model is significantly influenced by the source motion. Instead, we combine them to maintain the target motion precisely. This is the visualization of our motion editor. And this is the comparison between our model against the other SOTA methods. And we can see that from the observation from the quality result and the quantity result, it demonstrates that our superiority of motion editing. And this is the ablation study that's to demonstrate the significance of each proposed core component of our motion editor, and the results demonstrate that each core component has a positive impact on the performance of our motion editor. That's all. Thanks.